on pre-calculus lesson 22. What we're going to do is solve radical equations. To do that, we're going to give you some steps. Step 1, we're going to isolate the or a radical on one side. We're going to square both sides. We're going to solve. And then we're going to plug and check to make sure that the answers actually work, because sometimes they don't actually work when you plug them back in. Because remember, when you take the square root or something, you can have plus or minus, and that's the reason it might not work. So we're going to isolate the or a radical on one side. We're going to square both sides. We're going to solve, and then we're going to plug and check. If there's it could be that when you do that, another radical is produced, and if that happens, you got to start back over and isolate that radical and then square both sides, and it gets even nastier, as we'll see as we go. Okay? Everybody have that written down? So, number one, we want to isolate the radical. The radical that we're trying to isolate is square root x. In other words, we want to get the junk off of it. And the junk on it is multiplication. And so we undo multiplication by division, and we have square root x equal 4. So we have completed step 1 in that we have isolated the radical. Once the radical is isolated, we then square both sides. The square cancels the square root, and we get x is equal to 16. But we need to check it. So we're going to plug that back in. And so we would have 3 square root 16 equal 12. We need to verify that that's true. Square root 16 is 4, so we're going to have 3 times 4 is 12. We get 12 is 12. So the x equals 16 as the solution checks out, so we keep it. Any questions on number 1? So we isolate it, square both sides, solve, plug back in to check that the answer really does work for the problem. Okay? And these are getting more and more complex as we go. We'll see. Any questions on number 1? Number 2, we're wanting to isolate the square root. It has multiplication and subtraction on it. We're undoing to isolate. Which one do you undo first? Subtraction by addition. So we would have 5 square root x equal 10. Now we're going to undo multiplication by division. We get square root x equal 2. So we have isolated the square root on one side. Once it's isolated, we're going to square both sides. The square cancels the square root, and we get x equal 4. Once we get a solution, we don't just circle it. We have to verify that it really does work. So we'll need to plug that back in. And so we'll have 5 times square root 4 minus 4 equals 6. Square root 4 is 2, so 5 times 2 minus 4 is 6. 10 minus 4 is 6. 6 equals 6. And so we have verified that x equals 4 is truly a solution. Any questions on that? Okay. Any questions on the first two? Number 3, now there's junk inside the radical with the x, so that's going to get a little bit more complex. The square root is already isolated, so we move on to step 2, which is to square both sides. When we do, the square cancels the square root, and we get the radicand, 3x plus 18 equal x squared. We have an x and an x squared, which means that this thing is a quadratic. And if it's a quadratic, we have to set it equal to 0. So we're going to move those terms to the other side, which is going to give us x squared minus x minus 18 equals 0, because you have to remember to change the sign when you cross over. So because we had an x squared and an x, and we knew it was a quadratic, we're going to put that quadratic in standard form, meaning we set it equal to 0. We can try to factor if a is 1. Then remember that we can just put in our parenthesis an x here and an x here. And we can think about what you multiply to get 18, but add to get a negative 3, and we know it would be a 3 and a negative 6. It needed to be a negative 18. So 3 times negative 6 is negative 18, but 3 plus negative 6 is negative 3. And so we're going to have x plus 3, x minus 6. Understand how to factor with an a of 1. So now we set each factor equal to 0, so we say either x plus 3 equals 0 or x minus 6 equals 0. And so here we would get x equal negative 3, and here we would get x equal 6. So we have two possible solutions, but we need to check both out to see if they really work or not. But it's there, we got to there. So we're going to take the negative 3, plug it both places, right? So you would have square root 3 times an x of negative 3 plus 18 needs to come out to be equal to my x, which is negative 3. Over here, we're going to have 3 times my x of 6 plus 18 should come out to be equal to my x of 6. Right here, we're going to get square root 18, square root 9. 3 times negative 3 is negative 9 plus 18 is 9. Square root 9 equal negative 3. Square root 9 is positive 3. Positive 3 is not equal to negative 3. So this is not a solution. We say that it is an extraneous solution. Meaning that it solved, in the process of solving, it looked like an answer, but in reality, when you plug it back in, it's not. Okay? And if we plug this one in, we're going to get 18 plus 18 is 36, so we would have square root 36 equals 6, and that one is true. So we have one solution, x equals 6. The other was an extraneous solution and got cast out. Any questions on number 3? Let's just play with that just a second. Everybody got that? I'm going to go to my graphing calculator. I'm going to go to y equal. I'm going to clear that out, and I'm going to do square root of, what was it, 3x plus 18? And then I'm going to go down to x, right? You know that if you take an equation and you put the left side in y1 and the right side in y2, and you find the point of intersection, that's the solution. Y'all remember that from somewhere? So we're going to hit graph and see what we get. Let me do something. I've got some stuff in stat edit I need to get out. And I want to make my window a little bigger. So I'm just going to go from negative. I'm just going to go to a standard viewing window. So let me go to zoom, standard 6. Now I'm recording this and I'm having trouble. I may wish I hadn't have done this, but anyway. It's not letting me graph. Just a second. I should have paused. I didn't think about pausing my recording. Let's go back to y equal. I'm going to do square root. It was 3x plus 18. And then y equal x. Had something was in there maybe. There we go. There was just, I don't know where whatever was in my calculator, but it wasn't letting me graph. Okay. Do you notice that on this there's only one point of intersection? If I go to second trace and I go to intersect number 5, and I do first curve, second curve, first curve, second curve, and then I go about to the point of intersection, there's only one point of intersection, you see. And so the answer of 6 worked, but the other one didn't work. So even though when we solved, it appeared that there were 2 solutions, you can see graphically that there's only one because there's only one point of intersection. Okay? And it's kind of like if you thought about this thing continuing as a parabola, there might have been another solution there, but since it's not really a parabola, there's not really a solution there. So there's kind of the idea of that extraneous solution. We saw it, but it doesn't really exist in the graph of that situation. Okay? Sorry about the little delay in that. I had things hiding in my calculator that weren't supposed to be there. All right. So maybe that'll help visually think about what an extraneous solution is. All right, so now we're on number 4. Number 4, we already have an isolated square root, so we're going to square both sides. The square cancels the square root, and we have x plus 3 equal. Now, when we do x minus 3 squared, we're doing x minus 3 times itself x minus 3, right? And so when we do, you can send the x through and send the negative 3 through if you like it that way. X times x is x squared. X times negative 3 is negative 3x. Send the negative 3 through, negative 3x. And then negative 3 times negative 3 is positive 9. Combine like terms, x squared minus 6x plus 9. Or it's a binomial square, so you could say a squared minus 2ab plus b squared. Okay? So we have that is equal to x squared minus 6x plus 9. We see an x squared and an x, so again we realize that this is a quadratic. So we need to set it equal to 0. So we're going to send the x and the 3 across, remembering to change the sign. So that would be a minus x there and a minus 3 there. So we would have x squared minus 7x plus 6 equals 0. We again have an a of 1, therefore we can try to factor just by sticking an x here and here. We would think about the factors of 6, 1 and 6, and 2 and 3, but we need to get a negative 7. So negative 1 and negative 6 would give us a positive 6 when you multiply, and a negative 7 when you add. So we have a minus 1 and a minus 6. We've been around enough to know that if there's a factor of x minus 1, then there's a root of positive 1. If we have a factor of x minus 6, then we have a root of 6. But again, we have to plug those in to validate them. So when we plug the 1 in, both places for x, we would have square root of 1 plus 3 is equal to 1 minus 3. So we would have square root 4 equal negative 2. So we would get 2 equal negative 2, which is false. So this is an extraneous solution. So we have to cast out the 1. We'll try the 6. We'll have square root 6 plus 3 equals 6 minus 3. So we get square root 9 equal 3. So we get 3 equal 3. So we keep the 6. Cast out the 1. Any questions on the first 4? They get a little more complicated as we go. What we're going to start dealing with is a radical on both sides before we're done, and a radical in a radical. Okay? Now, on number 5, we need to isolate the radical. So we need to subtract the x. So we're going to have negative square root 2x plus 5 is equal to negative x plus 5. We've still got to get rid of this negative 1 that's understood to be multiplied. So we're going to divide by negative 1, remembering to distribute here. And so we'll have square root 2x plus 5 is equal to positive x minus 5 when we divide by the sign changer. This is a negative 1, right? Negative 1 here. So we got the square root isolated, so now we're going to square both sides. And the square cancels the square root, and we get 2x plus 5 equal. X minus 5 squared is x minus 5 times itself, which is going to be x squared minus 10x plus 25 if we FOIL it out, distribute it out, or use the binomial square rule. Again, we have a quadratic, so we need to set it equal to 0. So we need to shift those to the other side, remembering to change the sign when you cross over. So we'll have x squared minus 12x plus 20 equals 0. A is 1. So we can put our x's. What can we multiply to get 20 and add to get negative 12? 2 and 10. So minus 2 minus 10. Which means that my roots would be x equal 2 or x equal 10. That was weird. Paper covers rock. Rock, paper, scissors. Remember that paper, scissors, rock jump? In that, the eraser is always supposed to override the marker, but it didn't that time. I'm not sure why. Okay, so we need to check to see if those work. So we're plugging back into here. So we're going to have 2 minus square root 2 times 2 plus 5 equal 5. So 2 minus square root 9 equal 5. So 2 minus 3 equal 5. So negative 1 equal 5, which is not true. So we have to cast that out as an extraneous solution. Do what? 2 times 2 is 4 plus 5 is 9. And then square root 9 is 3. And then we're going to plug in the 10. So we would have 2 minus, we'd have 10. 10 minus square root 2 times 10 plus 5 equal 5. So 10 minus square root 25 equal 5. So 10 minus 5 equal 5. So 5 equal 5. So we keep the 10 and we cast out the 2. Any questions on that? Everybody good? All right. And number 6. I couldn't remember if there was a 7 and 8. This is the last lesson I'll record. I recorded all the algebra, all the geometry. Miss Ballard has recorded all the college algebra and trig. I've already recorded the second semester of pre-calculus, so this lesson is the very last lesson of about 10, 11 years, of 13, lots of years of stuff. Anyway, I was kind of anticipating the end a bit. Oh well. Okay, so this time we have 2 square roots, but what we're going to do is we're going to isolate one of them, okay? So we'll move this one to the other side, remembering to change the sign when we cross over. And so we're going to have square root x plus 8 equal square root x minus 4 plus 2. So we isolate. Remember I said you isolate the or a radical in the directions. We're going to isolate a radical. And then we're going to square both sides. And it cancels here. But over here we have this. And we have to multiply the first binomial through the second. So we're just going to send the x minus square root x minus 4 through and then the 2 through. Square root x minus 4 times square root x minus 4 is x minus 4. Because you basically squared the square root, right? That was this times this. And then we have square root x minus 4 times 2, which is going to be plus 2 square root x minus 4. It's 2 of those. And now we're going to multiply 2 times that is 2 more of those. And then we're going to multiply 2 times 2, which is a plain 04. Our minus 4 and our plus 4 cancel. So we have x plus 4 of those square root x minus 4s when we get done collecting all of our terms. So we have x plus 8 equal x plus 4 square root x minus 4. Let's see how we got that. So we isolated a radical and we squared both sides, but now we still have a radical. So now we have to isolate that radical and square both sides. Everybody with me so far? So to isolate it, we're going to undo addition first by subtraction, and we'll have 8 is equal to 4 square root x minus 4. That was kind of nice that those little x's disappeared. Now we're going to undo multiplication by division, and we have square root x minus 4 equal 2. We isolated the square root, squared both sides, but we had a new square root. So we isolated the square root again, and now we're going to square both sides. And now we can solve. So we're going to undo subtraction by addition, and we get x equal 8. That one only had one answer. Choice. We still have to plug that in to the original to see if it works. And so we would have square root of 8 plus 8 minus square root 8 minus 4 needs to be equal to 2. We're plugging into that. So we're going to have square root 16 minus square root 4 equal 2. 4 minus 2 equal 2. 2 equal 2. It checks out. And so we keep the x equal 8. Any questions on that? These are kind of neat. I like them. Any questions so far? All right. Number 7. Number 7, we have 2 square roots. We need to isolate one of the 2. So we're going to move this one to the other side. So we're going to have square root 2x plus 3 is equal to negative square root x minus 2 plus 2. Or you could have left it 2 minus square root x minus 2. We isolated a square root. So now, whoops, missed. So now we're going to square both sides. I'm going to put my negative back. The square cancels the square root, and we get 2x plus 3 over here. Over there, we have to think of this as negative, I'm squaring that side, square root x minus 2 plus 2 times itself. So we have to multiply all that out. A negative times a negative is a positive, and that radical times itself is the radicand x minus 2. I said we got x minus 2. Negative times a negative is a positive. Radical times itself is radicand x minus 2. And then we're going to have that times a second chunk 2, which is going to be minus 2 of those. And then we're going to do this, which gives us minus 2 more of those. And then we have a 2 times a 2, which is a 4, plus 4. We're going to combine like terms. We have an x, we've got a minus 2 and a plus 4, which is a plus 2. And then we have 2 of those, and 2 of those is 4 of those. So it ends up being x plus 2 minus 4 square roots of x minus 2. You understand what we did? Now, we isolated a square root and squared both sides. We have another square root. Now we need to isolate it and square both sides. To isolate it, we need to subtract x and subtract 2, which is going to give us x plus 1 equal negative 4 square roots of x minus 2. Now we're going to undo multiplication by division. We could distribute it, or we can leave it like that. Let's just leave it like that. And so we're going to have square root x minus 2 equal x plus 1 over negative 4. I'm just going to leave the negative. We don't like it, but we're fixing to square it, and it's going to get rid of it. So why deal with all that? You understand what I'm saying? So we isolated the second one, and we're going to square both sides. Those are going to cancel, and we're going to get x minus 2 equal something over 16, right? Because we're squaring the numerator and squaring the denominator. So then we'd have to come over here and do x plus 1 squared, which is x squared plus 2x plus 1. And we'll pause for everybody to catch up so you can tell me what we ought to do to make this look better. Good. We're going to multiply both sides by the denominator 16 because we don't like that fraction, right? So we're going to multiply by 16 to cancel that denominator, but we also have to do it over here. So that's going to give us 16x minus 32 is equal to x squared plus 2x plus 1. So we multiplied through by that denominator 16 to make there not be fractions. We realize we have quadratic, and we know that we have to set it equal to 0, right? So I'm just going to do my little errors. We're going to send that to the other side and send that to the other side, remembering to change the sign when you cross over. And so we're going to have x squared. Now we've got a 2x, And when we send that across, it's going to go over as a negative 16, and a 2 and a negative 16 is a negative 14. And then we've got a positive 1. When we send that negative 32 over, it's going to go over as a plus 32. 1 plus 32 is 33. And so we set our quadratic equal to 0. I said we got those numbers. Remember to see, this is going to be a negative 16, because when you cross over, you change the sign. So a negative 16x and a positive 2x makes that positive 14, that negative 14. And then a minus 32 is going to go across as a plus 32, and a plus 32 and a 1 is a plus 33. So we moved them across, remembering to change the sign. A is 1, and so we can factor like this. What can you multiply to get 33 and add to get negative 14? 3 and 11, both negative. So if the solutions, if the factors are x minus 3 and x minus 11, then the roots are x positive 3 or positive 11. Set them equal to 0 and solve, we understand. But we still have to plug them back in to see if they work. These get kind of big. So we're going to plug these in. If we plug them in, we would have square root of 2 times 3 plus square root of 3 minus 2 needs to come out to be 2. So we plugged in the 3 in place of x. So we're going to have square root 9 plus square root 1 equal 2. So we get 3 plus 1 equal 2. So 4 equal 2. Not true. So we have to cast out the 3. It is an extraneous solution. Then we'll try the 11. So we're going to have square root of 2 times 11 plus 3 plus square root of 11 minus 2 needs to come out to be 2. So square root 25 plus square root 9 needs to come out to be 2. So 5 plus 3 needs to come out to be 2. So 8 needs to be equal to 2. And it's not. So we have to cast that one out too. So they're both extraneous solutions. And so there's no solution. What does that mean? They don't cross. It means if we put this in y1 and we put that in y2, y equal 2 is a horizontal line at y is 2. It means that when you graph this thing, it never crosses that line y equal 2, right? You could verify it graphically. Let me do that just in case we didn't catch that. If we went to the graphing calculator and we went to y equal and we put in square root, what was the first one? 2x what? Plus 3. And then plus, what was the second part? X minus 2. And then down here we put a 2, which is a horizontal line, and we graphed. You could see that they're never going to hit. So we got a couple of answers, but they're not really answers. Graphically speaking, we can see that they're extraneous because those answers do not appear in the intersection of those two things. Okay? Any questions on that? All right. And then number 8, we'll do next time. We have a radical and a radical. So we get to do one more video. We thought this might be the last one.